Today we are going to be talking about complex fractions. So a complex fraction is a fraction where either the numerator or denominator or both is a fraction. Or mixed number it could be. So this is an example, 1/2 over 5/7. That really means 1/2 divided by 5/7. So we're going to solve some problems that have complex fractions. Number 1. Julia rides her bike at a rate of 1/2 mile per 1/9 of an hour. How far does she ride in 1 hour? So, if we think about this as the same thing as a proportion word problem, we are comparing miles and hours. So we are given 1/2 of a mile per 1/9 of an hour. And we want to know how far does she ride in 1 hour. So 1 matches with the hour. We're solving for that top part there. So it would be the same thing. If we look at our diagonals to solve, really, it just becomes 1/2 times 1, which is 1/2, divided by the number that's in the same diagonal as the variable, which is 1/9. So now I'm going to write this with an actual division sign. So we have 1/2 divided by 1/9. When we divide fractions, we have to keep it, switch it, flip it. So keep it as 1/2, switch it from division to multiplication, flip it from 1/9 to 9/1. Now I would double check my diagonals. Do any of those simplify? Nope. So I'm just going to multiply across. 1 times 9 is 9. 2 times 1 is 2. You can leave it as 9/2, or 2 goes into 9 4 times with 1/2 left over. So how far does she ride? 4.5 miles. Number 2. Leo read 1/10 of his book in 1/4 of an hour. At this rate, how much of his book will he read in an entire hour? So if we set this up as a proportion, we are comparing the book to hours. So if we look at this problem, we have 1/10 of his book, so that's going to go on the top here, and 1/4 of an hour, that's going to go on the bottom. At this rate, how much of his book will he read in an entire hour? So that means in 1 hour. We are solving for the book. So I can look at it like a proportion and look at these diagonals, which means I would be doing 1/10 times 1, which is just 1/10, divided by the number in the same diagonal as the variable, which is 1/4. So that is our complex fraction. I'm going to write this like a division problem. So 1/10 divided by 1/4. We have to keep it, so keep the first number, switch it from division to multiplication, flip it from 1/4 to 4/1. I'm going to simplify my diagonals before I multiply across. 1 and 1 are already simplified. 4 and 10 divide by 2. So 4 divided by 2 is 2. 10 divided by 2 is 5. Now I'm going to multiply across. 1 times 2 is 2. 5 times 1 is 5. What were we solving for? How much of his book will he read? So 2/5 of his book. Number 3. Renee needs 1/3 cups of sugar to make 1/4 of her cookie recipe. How much sugar does she need to make the entire recipe? So if we set this up as a proportion, we are comparing sugar to recipe, the cookie recipe. So she needs 1/3 cups of sugar to make 1/4 of the recipe. How much sugar does she need to make the entire recipe? So one whole recipe, we want to know how much sugar she needs. If we look at this as a proportion, I can highlight my diagonals. I would be multiplying 1/3 times 1, which is just 1/3, dividing by the number in the same diagonal as the variable, which is 1/4. So I'm going to set this up, my complex fraction, as a division problem, 1/3 divided by 1/4. Then I'm going to keep it, switch it to multiplication, flip it from 1/4 to 4/1. Before I multiply across, I'm always double checking my diagonals if they simplify. They don't simplify by anything other than 1, so I'm just going to multiply across. 1 times 4 is 4. 3 times 1 is 3. We can leave this as 4/3 or make it a mixed number. 3 goes into 4 once with 1/3 left over. So what were we solving for? We were solving for how much sugar. So 1 1/3 cups of sugar. Scott can hike 1.5 miles in 2/3 of an hour. How far can he hike in 1 hour? So again, setting up a proportion, we're talking about miles and hours. So we've got 1.5 miles and 2/3 of an hour. How far can he hike in 1 hour? So 1 matches with hour. We are solving for how far or how many miles he can hike. Let's look at this proportion to solve. So the two numbers that I'm multiplying together, 1.5 times 1 is just 1.5, divided by the number with the variable is 2/3. We've got our complex fraction. I'm going to set it up as a division problem. 1.5 divided by 2/3. So all three problems that we've done so far have just been fractions. Now we have mixed numbers. Before I keep it, switch it, flip it, I have to change my mixed number into an improper fraction. So 1 1/2, you do 1 times 2 is 2, plus 1 is 3. So this really is, I'm going to write it over here, 3/2 divided by 2/3. Now I'm going to keep it as 3/2, switch it from division to multiplication, flip it from 2/3 to 3/2. Now before I multiply across, I'm double checking my diagonals to see if those can simplify. 3 and 2 only divide by 1, they do not simplify, so I'm just multiplying across. 3 times 3 is 9, over 2 times 2 is 4. I can leave it as 9/4 or make it a mixed number. 4 goes into 9 twice, which makes 8, and has 1/4 left over. What were we solving for? We were solving for how far he can hike, the number of miles. So 2 1/4 miles. Leanne is sewing new curtains for her bedroom. She bought 3.5 yards of fabric. Her total cost was $12. What was her cost per yard? So I'm going to set up my proportion. We are given 3.5 yards of fabric, so we're comparing yards, and $12 for the cost, so we're comparing a cost. So 3.5 is talking about the yards, and 12 is talking about the money. And then the question says, what was her cost per yard? That means per 1 yard. Yards is on top, so I'm going to put my 1 here, which means we are solving for the money. I'm going to check my diagonals to solve this proportion. So in this case, I'm multiplying 12 times 1, which is just 12. And I'm dividing by the number with the variable, which is 3.5. Now that I have my complex fraction, I'm going to rewrite this as a division problem. So 12 divided by 3.5. Same thing, we've got some mixed numbers and some whole numbers, so we need to rewrite these as fractions or improper fractions first. 12 as a improper fraction is 12 over 1 divided by, and don't try to just skip to the multiplication because that's when you tend to make mistakes. 3.5, which as an improper fraction, 3 times 2 is 6, plus 1 is 7 over 2. Now I'm going to keep it, switch it, flip it. So keep it as 12 over 1, switch it from division to multiplication, flip it from 7 over 2 to 2 over 7. Now I'm going to look at my diagonals to see if I can simplify. I cannot, so I'm going to multiply across. 12 times 2 is 24. 1 times 7 is 7. I can leave it like that, or I can make it a mixed number. 7 goes into 24 3 times to get you to 21 with 3 left over, so 3 7s left over. What were we solving for? The cost. So 3 3 7 dollars, which is kind of funny to say, per yard. And the last one, a pool is being filled at a rate of 30 1/4 gallons every hour. Express this rate as a unit rate per hour. So we're going to set up a proportion and look at the numbers that are given to us. Shouldn't say every hour, let's say every 4 hours. Sorry. So we have 30 1/4 gallons, and we have 4 hours. We're comparing gallons and hours. So 30 1/4 is gallons. I'm going to put that on top. 4 is talking about hours. I'm going to put that on the bottom. And then we are solving per hour. So per 1 hour, we are solving for the gallons. I'm going to highlight my diagonals and solve this proportion. I'm going to multiply 30 1/4 times 1, which is just 30 1/4. And we are dividing by the number in the same diagonal as the variable, so to divide by 4. I'm going to turn my complex fraction into a division problem, so 30 1/4 divided by 4. Before I keep it, switch it, flip it, I need to rewrite these as improper fractions. 30 1/4 as an improper fraction. 30 times 4 is 120, plus 1 is 121 over 4, divided by 4 as a fraction is 1 over 4. Nope, 4 over 1. Sorry, I'm jumping ahead here. Now I'm going to keep it, switch it, flip it from here. So keep it as 121 over 4, switch it from division to multiplication, flip it from 4 over 1 to 1 over 4. I'm going to double check my diagonals to see if anything simplifies. 121, you might not have memorized what it divides by, but 4 only divides by 1, 2, and 4. And since 121 is odd, it's not going to divide by 2 or 4. So they don't simplify. I'm just going to multiply across. 121 times 1 is 121. 4 times 4 is 16.